Welcome to the first of these revision videos. This is going to cover movement and position, part of forces and motion, chapter 1 of the IGCSE specification. I'd recommend that you had pieces of paper to write on. You can try things out, and at various points I might invite you to pause the video to have a go at problems before I give you the solution. But remember that you can rewind anytime and re-watch explanations. Let's start by revising scalars and vectors. Okay, try to place the quantities to do with motion that I've listed on the right, distance, speed, velocity, acceleration, and force, underneath the two headings, scalars and vectors. Pause the video and try this now. Okay, done? Okay, so hopefully you've got those right. Distance and speed only have a size, whereas velocity, acceleration, and force, they do have a size, but they also have a direction. Okay, next, there are three equations that you need to know which relate these quantities. So, first of all, the symbols for distance, speed, velocity, acceleration, and force are S, U, or V for speed, U or V for velocity, A for acceleration, and F for force. In fact, we won't be worrying too much about force now because we're only discussing motion. Remember that U is the initial speed or initial velocity and V is the final. So, in the space I'm outlining here, I'm going to write down the three equations that you need to know for this topic. 1, 2, and 3. Have a go at writing them yourself now. Are you done? Okay. The first one's average speed equals distance travelled over time taken. Remember, as with all equations, in order to get a unit of meters per second on this side, the distance travelled has to be in meters, the time taken has to be in seconds. Number 2, A equals V minus U over T, where V minus U is the final velocity minus the initial velocity, also known as the change in velocity. That is in meters per second. You divide that by another seconds. So the unit of acceleration, as you know, is the meter per second squared. And the final equation is final velocity squared, v squared, equals the initial velocity squared plus 2 multiplied by the acceleration multiplied by the distance travelled, which the standard symbol for is S. S is not speed, it's distance travelled. Okay, now let's look at some example problems. Okay, have a go at each of these three problems using the equations I just wrote down. Pause the video and have a go. Okay, I'm going to work through these quickly live. So, a car travels 15 kilometres in 20 minutes. Its average speed is, the formula is average speed equals distance travelled over time taken. Now, we want this in meters, and I'd rather have this in seconds so that I got my average speed in meters per second. So 15 kilometres is 15,000 meters multiplying by 1,000. 20 minutes is 20 times 60 seconds. So we're going to have 15,000 divided by 1,200. Which is equal to 12.5 meters per second. Okay, question 2. We're using A equals V minus U over T. Now, a 50th of a second, we need to convert to a decimal. A 50th is 0.02 or 200ths of a second. The speed, the final speed or velocity is already in meters per second. From rest indicates it starts with a velocity of 0 meters per second. So we've got 750, the final velocity minus 0, divided by 0.02, which is 37,500 meters per second squared. And finally, the bullet travelling in that time. So we want a distance, S. Now, I've already given you a clue that we're using this equation. If we think what we know, well, we know the initial speed of the bullet, that was U, which is 0. We know V, the final speed. We know A. So we can actually use this equation to work out S. So V was 750. We square that. U is just 0, so we've got 0 squared. Acceleration, so 2 times the acceleration, which was 37,500, multiplied by S, gives us 750 squared is 2 times 37,500 times by S. So S is going to be 750 squared divided by 2 times 37,500. Again, you can pause and or re-watch that if you're not clear on that substitution, or rather rearrangement. And then we get 7.5 meters, which is quite a nice round number, really. Okay, the next thing I'd like to do is look at graphs of motion. So what I'd like you to do over here in this space is to sketch lines or curves to show the following types of motion, the types of motion I've written down the left-hand side of each plot. So for instance, on a distance time graph, stationary would be a straight horizontal line of 0 gradient to show no distances being covered. Do the same for each of those types of motion. Pause the video and have a go. Are you done? Okay, here are the solutions. Hopefully they match what you sketched. Note that on a velocity time graph, any straight line with a positive gradient is constant acceleration. Any straight line with a negative gradient is constant deceleration. Okay, the next bit is to do with how we can work out speed, acceleration and distance travelled from distance time and velocity time graphs. You can see that I've got a summary here. In short, to find the speed from a distance time graph, we work out the gradient. To work out the acceleration, we use the gradient of velocity time graph, and you hopefully remember that the area under a velocity time graph gives the distance travelled. Pause on this screen now if you want to read further. Okay, to finish, let's put some of this into practice by looking at this exam question, or part of this exam question. If you'd like, you can pause at this point to have a go at some of these yourself. Right, let's go through this. So I'm going to do this live again. So starting at the top, state the relationship between acceleration, velocity and time. You can write the word equation. I'm going to write the symbol equation. Notice that I've got the symbols all correct. Final velocity minus initial velocity u over time. It's always worth checking units. So it says the sledge starts from rest and accelerates at 1.5 meters per second until the velocity is 2.8 meters per second. We're told here the initial speed is 0 meters per second, remember, because it says at rest. Now, if we want the time taken, we want to take our equation and rearrange it so that t is the subject. So what that becomes is, if we do it in 2 steps, at equals v minus u, and then t is v minus u over a. So if we put the numbers in, we get 2.8 minus 0, the initial speed at rest, divided by the acceleration, which is 1.5. That gives us 2.8 divided by 1.5, which is 1.87 seconds. Part C. Calculate the distance travelled by the sledge. Here we want the area underneath the line. Okay, so all this area underneath the 3 segments of line. So that goes between 0 and 14.5 seconds. If you look at the scale, you can split this into 2 triangles. Now, if you look carefully where this point is, this is 2.5. And then this point here is at 10.5. So we've got over here a triangle with base 2.5 seconds, and over here a triangle with base 4 seconds. We've got a rectangle in the middle, which extends between 2.5 and 10.5, so it's 8 seconds. And the height of all of these the two triangles and the rectangle is 3.25 meters per second. So the overall distance travelled is going to be composed of 3 parts. We're going to have one triangle, a rectangle in the middle, and then the triangle at the end. So you can see I've worked these out. The sum of them all is 36.6. That's quite a lot of working to do for 3 marks, but there you go. It's 2 triangle areas and a rectangle area, and add them together. The equation linking average speed, distance moved and time taken, as we said before, is average speed equals distance moved over time taken. And then finally, 3, calculate the average speed of the sledge for the whole journey. Well, we know that the average speed V, let's call it VAV, is going to be the distance moved over the time taken. So it's going to be 36.6 divided by the time taken for the whole journey, which from the graph is 14.5 seconds, which equals 2.52 meters per second. Okay, I hope that was useful. If we return now to the syllabus statements, what you can do is you can check through each of these and make sure that you're happy with each of them. This one, 1.5 in the middle, I'm going to make a separate video that deals with the practical aspects of the course. So watch out for that. Thank you.